In this example, we're going to use the empirical rule again, and the question states, the physical plant at the main campus of a large university receives daily requests to replace fluorescent light bulbs. The distribution of the number of daily requests is bell-shaped and has a mean of 37 and a standard deviation of 8. Now, that bell-shaped word is another word for saying that it's a normal distribution. And we're going to use the empirical rule to approximate a percentage of light bulbs between 21 and 53. Now it says the mean is 37. And it says the standard deviation is 8. So as I come out each standard deviation and to the right, I'm going to add 8. So to the first standard deviation out, I'm going to add 8, and that's going to give me 45. When I come out another standard deviation, I add 8 again. That gives me 53. And when I come out another standard deviation, that gives me 61. Now, when I come out to the left, I have to subtract. So I'm going to take 37 minus 8. That's going to give me 29. And then if I subtract 8 again, that's going to give me 21. And then if I subtract 8 one more time, that's going to give me 13. So I have all my standard deviations set up. Let me adjust my color here so we can see the difference. Okay, so this is the mean. So this is 0 standard deviations away from the mean. This is 1 standard deviation. This is 2. This is 3. This is -1. This is -2, and this is -3 standard deviations away from the mean. So we can see the difference between our z's and our raw scores, which are our x's. Now, the empirical rule says if I come out 1 standard deviation in either direction, I have 68% of the data falls between 1 standard deviation out in either direction. So from here to here in this center area, that's 68%. Now, because the graph is symmetric, although my drawing doesn't look all that great, but it's supposed to be symmetric, I know if I take 68 and split it in 2, that gives me 34 in each of these sections, 34%. Now, if I come out 2 standard deviations in either direction, I know from this line here to this line here is 95% of the data. If I subtract these two 34s, what I have left is 27% of the data. So I know 27% of the data has to fall in this area here and then this area here. So if I take 27 and divide by 2, I know that this area here covers 13.5% of the data, and this area here covers 13.5% of the data. If I keep using that logic and I keep coming out, if I go out 3 standard deviations in either direction, I know that that covers 99.7% of the data approximately. So if I take 99.7 and I subtract what we already have in here, which is 95%, what's left is 4.7% of the data. And then I have to split that 4.7 up into these two areas. So if I take 4.7 and divide by 2, then this area here is 2.35% of the data. And then this area here is 3.5% of the data. Oh, sorry. Let me erase that. I meant 2.35. Okay, so then what's left, if I take and I find what's left in these little wings here on either side, the extreme values, I know that the total area under the curve needs to be 100%. And I know between the three standard deviations out in either direction, that covers 99.7% of the data. So if I take 100 and I subtract 99.7, what's left is 0.3%. So now I got to take that 0.3% and split it on either wing. So I know that this little wing here on the left is 0.15% of the data. And then on the right, this is 0.15% of the data. So now we have our graph all set up. Once we have our graph all set up, it's really, really easy to answer this question. So what I would suggest, if you haven't already done so, to make sure that you have a copy of this and keep it as a template somewhere so that you can use it again and again and again for your homework questions. These numbers down here might change depending on what the mean and the standard deviation is for each problem, but the areas between these lines is not going to change. Okay, so now the question is asking what percentage falls between 21 and 53? Well, here's 21. Here's 53. So I just have to add up all of these percentages. So I have to take 13.5 plus 34 plus 34 plus 13.5. And when I add all that up, I get 95%. So approximately 95% of all the light bulb requests fall between 21 and 53 light bulbs. Now, if I added another part to this, let's say I asked what percentage falls between 13, I'll just add a question down here, 13 and 29. If I asked what percentage falls between 13 and 29, then let me do this in a different color. Let's use red. Then I'm looking for between here and here. So I would just take 2.35 and add 13.5. And I would get 15.85. So once you have this set up with all the percentages underneath, you can reuse it for multiple parts of the question or for different questions in a different homework assignment. But this is only applying to questions that says approximate it with the empirical rule, and this only applies to the normal distribution.